All right, so we're going to briefly talk about graphing logarithms. Okay, just to reintroduce some ideas here about logarithms, try and reconnect some stuff. So graphing logarithmic functions. We won't take too long on this. Won't take too long, I don't think. All right. So I want to give you time, of course, to work on your homework here in class. But also I want to give you time to look at that yellow packet, as I have a feeling that some of you haven't been. So I wanted to give you a chance to work on it in class here. All right. But before we get into the graphing, I wanted to review, or at least clarify, okay, something important here, okay, and that is what is a logarithm? Okay, what is a logarithm? Why is it a thing that we even bother ourselves with, okay? And no, the answer is not to torture you, okay? That's just a fun side property, all right? So a logarithm, okay, the best kind of like analogy that I could give, okay, why a logarithm exists or what is a logarithm, the best kind of analogy I could give for you, I think, is that a logarithm is like a square root, right? Why do square roots exist? Because squares exist, right? And in order to cancel out a square, you have to square root it, right? They're inverses of each other, right? If you want to find the inverse of a square function, like x squared, for example, if you want to find the inverse of x squared, you would need to know to take a square root, right, in order to find the inverse. Logarithms are also inverses as well, okay? So in the same way that a square root is the inverse of a square, a logarithm is the inverse of an exponential. Okay, function, I guess we'll say. Okay, a logarithm is the inverse of an exponential function. Okay, so what do I mean by an exponential function? An exponential function looks like this, right? It's got a base and it's got x in the exponent. That's an exponential function. All right. How do we find an inverse for any function? What do we do? Well, the first thing, right, is we change it to y equals b to the x, right? Then what do we do with our x's and our y's? To find an inverse. Switch them, right? Okay? This is something we've been doing since the very beginning of this class, right? With some more success than others, right? But this is something we should be able to do, is find the inverse here, okay? So we change f of x to y, swap the x and y, and now we want to get the y by itself, right? We want to solve for y, but the y is up here in an exponent. Okay. Y is in the exponent here. So what can we do to get the y out of the exponent? Well, remember, right? This is exponential form. We can rewrite this using logarithmic form. Okay? So let's change this exponential form to a logarithmic form. It'll be log base what? What's the base of our exponent here? What's the base? Not the x. B. B is the base. B is the base because it's got the power there, right? It's got the power of y. So b is the base. So this is going to be log base b of what goes inside the logarithm? I know it's weird because we have all these exponents and stuff like that. But all these variables and stuff like that. But one of these, either the x or the y, goes inside. Which one goes inside? Y. It's not the y. It's the x. Yeah, it's the x there. So log base b of x equals, and then what's it going to equal? What's the other variable left over? Y, okay? And so there's our inverse, okay? So f inverse of x is log base b of x, okay? So we have the original function, and then we have its inverse right there, okay? And again, that was just using the definition of logarithm, right? Logarithmic form. This is exponential form, right? This is the rewritten in logarithmic form right down here. Okay? All right. You will need to be able to rewrite from logarithmic to exponential form tomorrow, for example. Okay, you'll need to be able to do that. Rewriting an exponential and logarithmic form tomorrow, so make sure you can do that, okay? All right. So these are inverses of each other, okay? Which means their graphs will be related too, all right? We already know how to graph an exponential function. Let's just review that here real quick. So let's graph, for example, f of x equals 2 to the x. Okay, we'll just graph this. And then we'll compare it to the graph of its inverse, log base 2 of x. Okay, so let's graph f of x equals 2, or sorry, f of x equals 2 to the x. So we'll make a little table here. And we'll pick some values for x. Let's do like 0, 1, and 2. I'll also pick -1 and -2. Okay. Let's do the easy ones first, right? What's 2 to the first power? 2 to the first? 2 to the 1 is 2. Yes. No, it's 2. Yes. It's 2. Okay. What about 2 to the second power? 2 to the 2? 4. Okay. What's 2 to the 0th power? No. 1. 1. Yeah, it's 1. How about 2 to the -1? Not -2. Nope. 1/2. Very good. Yeah, very good. It's 1 over 2 to the 1, right? Or 2. 1 over 2. How about 2 to the -2? What's that? 1/4. Very good. Okay. Good. 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 Some of you guys remember that stuff. Of course, if you ever get stuck, right, you can always type it in your calculator. You know, just plug in. You know, in your calculator, you can just literally type in there. You know, 2 to the -2. Right, like I've got right there. Hit enter, and you get 0.25, or math enter, enter, 1/4, right? Convert it to a fraction. Okay, so let's plot these points here again. We've done this before. All right, so 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so -2, 1/4, that's like really low, and then 1/2 is like right there, and then 0, 1, 1, 2, 2, 4. Okay, remember this is how we started out this unit, graphing exponential functions. Okay, whoops, there you go. What was the domain of this function? What's the domain? -infinity to positive infinity. Okay, what's the range of this function? Is it also -infinity to positive infinity? No. What's the lowest y value we're going to be approaching here? 0. Okay, so domain -infinity to infinity. But the range, though, right, the range has a lowest y value of 0. Okay. And since we have that lowest y value of 0, since our function here approaches the y-axis, right, we get closer and closer and closer to the y-axis, what other kind of special thing do we have here at 0? It's a what? A horizontal asymptote. We have a horizontal asymptote at y equals 0. Right? Is our graph going to have any zeros? Will it cross the x-axis? Is this graph going to cross the x-axis? No. Can't, right? We're going to do powers of 2 here. There's no way for some power of 2 to give us 0, right? Or there's no way to do a power of 2 that gives you a negative number either. So we're never going to cross the x-axis, so there are none. Okay, but we do have a y-intercept, and the y-intercept is at 0, 1. Okay. Right, so that's all the stuff for 2 to the x. That should be, hopefully, if not familiar, then it should be like, oh yeah, we did talk about that. Okay, I guess familiar, I guess. Hopefully that will bring some memories back. Pleasant memories. Now let's graph log base 2. Okay. When we go to graph inverses, right, we have to be a little more careful about what x values we pick. When we go to graph inverses, we have to be a little more careful about how we pick things, right? When we graph x squared, when we graph x squared, right, it's easy to pick any x value and square it, right? We can square stuff no problem. But then when we go to graph its inverse, the square root of x, right, we don't want to pick just any old x value because we can't really easily square root any value, right? We want to pick perfect squares, for example. Well, here the same thing. They're a similar idea. Okay, when we go to evaluate log base 2, we want to be careful about what x values we pick. Okay? Because remember, when you put in a number here, when you do log base 2 of x, you're trying to figure out what power of 2 gives us x, right? So in other words, the x values you pick, you want them to be powers of 2. So let's do like, 2 and 4. Okay? 1 is also a power of 2, but so is like 1/2 and 1/4. Those are also powers of 2. Okay? So let's imagine plugging these in, right? I'll plug in 2 first. Log base 2 of 2. Or in other words, 2 to what power will give us 2? 2 to what power will give us 2? First, yeah, 1. How about 4? Let's plug 4 in. So log base 2 of 4. 2 to what power will give us 4 when we plug that in? 2. Okay, how about 1? Log base 2 of 1. 2 to what power gives us 1? 0. 2 to what power gives us 1/2? Negative 1, very good. 2 to what power gives us 1/4? Negative 2. Okay? Notice the two tables here. What do you notice about the two tables?
They both have fractions, but no, they're flipped.
They're flipped, thank you. Yes, the x's and y's switch. Now wait a minute. Inverses, how do we get an inverse? What's the first step we do when we try and find an inverse? Swap the x and y's, right? Swap the x and y's. And these two functions are inverses, and look, the x's and y's are swapped. Okay? So, if you want to graph log base 2 of x, think about how you might graph 2 to the x. Okay? And then just create your little table, and then just swap the x and y values, and you'll have points for the log base 2 of x. Okay? So again, if we think about 2 to the x, okay, create a table for that, then your table for log base 2 of x will just be x's and y's all switched. That's it. So let's see what this is going to look like. All right, so let's plot these points. We have now 1/4, -2. So I'm going to go right 1/4 and then down 2, so something like that. And then right 1/2, down 1, and then 1, 0, 2, 1, and then 4, 2. So here's what our graph looks like now. In fact, I'll do it in red so it stands out more. Okay? So there's our graph. What is the domain? What does it look like the domain is for this graph? What's the farthest left it looks like we're going to go? According to this graph. 0. Is that what I heard? 0? Yeah, 0. We're never going to get there. And what's the farthest right looks like we're going to go? Infinity. Yep. Okay, let's look at the range. Okay, what's the lowest y value it looks like we're going to go to? Negative infinity, yep. Okay, what's the highest y value we're going to go to? It's going to keep going, I think. It's actually going to keep going. We're going to keep going up and up and up. Okay? And again, there's that same principle. Compare your domain of log base 2 with the range of 2 to the x. They're the same. Compare the range of log base 2 with the domain of 2 to the x, and they are the same. And why is that? Well, because in inverses, right, the x's and y's, they switch, right? So the domain, which describes the x's, becomes the range in the inverse function. The range, which describes the y's in the original, right, describes the x's in the inverse function. Okay, they switch. All right, which means this horizontal asymptote at y equals 0 is going to actually become a what kind of asymptote now? a vertical asymptote at not y equals 0, but x equals 0. Yeah. And instead of having a y-intercept at 0, 1, we're now going to have a 0 or x-intercept. An x-intercept at 1, 0. Okay, so everything flipped. Everything flipped. Okay, domain switched to the range switched to the domain. Horizontal asymptote becomes a vertical asymptote at x equals 0. There's no of the 0 that didn't exist. Okay, and the y-intercept that did becomes, well, a 0 that does exist at 1, 0, and now there's no y-intercept. Okay, so everything kind of switches there. Everything kind of flips. Okay? Questions on any of that? All right, so let's do one other one real quick here. We'll just do the table for this. So let's talk about 10 to the x. Okay, let's make a little chart for 10 to the x. Okay, so again, I'll pick the same kind of x values there, -2, -1, 0, 1, and 2. Okay. What is 10 to the 0th power? 1. What's 10 to the first power? 10. 10 to the second? 10 squared? 100. Good. How about 10 to the -1? What's that going to give us? 1 over 10, right? Again, like you're dividing by 10 when you go backwards, right? Divide by 10, divide by 10, divide by 10, so it's 110. What's about this one? What's this one going to be? 10 to the -2. 1 over 100, yes. Okay? So, let me just finish up this real quick, if you can. If you don't mind, I'm almost done here. Sorry, I just want to finish it. Bless you. All right, let's talk about the inverses then. What would be the inverse function of 10 to the x? So again, 2 to the x, its inverse was log base 2 of x. So 10 to the x, its inverse will be log base 10, which we don't need to write the 10, right? We could just say log of x, right? Because when you don't put a base, we assume it's 10. And what would its table be? Well, what would the y values be? -2, -1, 0, 1, and 2, right? We swap them with the x's, and then our x values will be 1 100th, 1 10th, 1, 10, and 100. And there's your table for log base 10, or just log of x. Okay? So that's what you could do there. All right. Questions on any of that? So you're going to be graphing a few of these here in a bit. I just want to make sure we're okay. All right. So to, oh yeah. Okay. Let me show you one other thing here with the logarithms. Of course, with any logarithm, we can talk about transformations, right? We have the a, the log, base b of x minus h plus k, right? I'm not even going to bother writing this out. What's a going to do to our graph? We should know this by now, right? What does a do? Stretch or shrink. If it's negative, that's also going to be a reflection over the x-axis. What's the h going to do? Left or right. And again, remember, it's the opposite of what you'd expect. So if it's a minus a number, that means you're going to shift right. If it's a plus number, you're going to shift left. And the plus k on the outside is going to shift it up and down. Exactly right. All right. And then for the last thing I want to show you here is how you can do logarithms using your graphing calculator. Okay, or how we can write logarithms into our graphing calculator. Okay, so let's just say, for example, we wanted to use our graphing calculators to help us graph log base 10 or how to graph log base 2. Okay, if I want to actually use my graphing calculator to do it, here's how you're going to do it. Log base 10 is easy. Okay, log base 10 is easy because we have that button. There's an actual button here for log base 10. So you press that. There's log base 10. You can hit X, close parentheses, graph it, and there's log base 10 right there. Okay, I'll graph 10 to the x at the same time so you can see the relationship there. And I'll put zoom square there to help it. So there's log base 10. There's 10 to the x. And if I graph the line y equals x, you'll see, right, there's 10 to the x. there's log base 10 of x. And you can see that they are reflections of each other over this diagonal line, y equals x. Okay? And you can go to your table, of course. Oops, let me do this. You can go to your table, of course, and get points for log base 10 of x easily, right? Let's see here. There's 10, 1, like we said, et cetera, et cetera. Okay? Alternatively, right, how do we graph log base 2? Well, to graph log base 2, there's a couple ways to do it. I'll show you one way here. You're going to press the math button to do a logarithm of a different base. You're going to press math, and you're going to go all the way down till you see this, log base. Now, if you have the pretty type calculator like mine, you get blanks to fill in. Okay? If you don't have the pretty type calculator, then, well, it'll be a little bit trickier here. So we'll just type in log base 2, and then I'll put an x in. And there I can do log base 2 of x. Okay? And so you can graph that. And then there's log base 2 of x. I'll also graph 2 to the x as well, so you can see it. And I'll graph the x, so you can see that line of reflection. So there's 2 to the x, and then there's line of reflection. Okay, you can see how they are reflections there. Okay? By the way, that log base command you can also use if you really want to. So for example, if I ever ask you, like, hey, what's log base 2 of 8? Right, you can type it in your home screen there, and then voila, you get 3. Right, 2 to the third gives you 8, so 3 is your answer. Now, for those of you that don't have the math print, let me turn it off here. Okay, so you can still use that log base command. Okay, but yours looks like this. Okay, so I think you have to type in the base first, comma, and then the number that you want to evaluate. So like 2, 8. Okay, so I'm pretty sure, let me just make sure this is right. Nope, that was wrong. Okay. So log base, you want to write the number and then comma the base. There you go. Okay. So in other words, for this, I'll put it on the notes here too. Okay. In the calculator, you're going to say log base, okay, and it's going to be 8, 2 is equal to log base 2 of 8. Okay, so the first number in log base is going to be the big one. The second number is the base of your logarithm. I think that's kind of weird that they did it out of order like that, but I guess it makes sense. Okay, so please make sure if you're going to use your calculator. All right. So in other words, if you want to graph, if you want to graph log base 2 of x in your calculator, you would do log base x comma 2 like that. Okay, so if you want to graph log base 2 of x in your calculator, you can see it would be log base x comma 2 to graph, log base 2 of x. Okay? All right. Sorry, CJ. Thanks for waiting. You can go there. All right. So your assignment then, what I'd like you guys to work on, it's out of the book. Okay, just to make sure you're comfortable with this. Starting on page 561, I'd like to do numbers 3, but only identify transformations. Okay, it's number 3. And then I'd also like you to do numbers, and I have what I assigned before. 4, 6, and 7 looks like. Okay, and so these are graphing and identify domain range. Okay, so page 561, number 3, only identify the transformations, and then 4, 6, and 7, those are graphing, and I want you to identify the domain and range and stuff too. Okay, you can use your graphing calculator to help you with that. Once you finish that up, or if you don't want to work on that, you want to try something different, you can go to the yellow packet here that I gave you for the review. Okay, so yellow review. Okay, and now we should be able to answer numbers without, numbers 1 through 15. 6 is a new addition, okay, to that list. And then 19 through 21 still. 23, I'm going to say 25 as well now. Okay, so 25 is also a new addition.
What module is the lookup?
Oh, sorry, good question. It's 15-2. 15-2. You're welcome. Okay. 15-2. All right. So go ahead and get started on that. Either pull it up on the book, or you can work on the yellow packet there.